and welcome back to Study Room. In the previous lecture, we started a new chapter of mathematics that was factorization. I taught you how to factorize the given algebraic expressions using two different methods of factorization. The first method that I taught you was the method of common factor method, and the second method was the method of regrouping the terms. And in that way, we factorized several algebraic expressions that was given to us. Now, in today's lecture, we'll be learning a new topic of factorization, that is factorization using identities. Now, you must be wondering, what are identities? So, let me make it clear to you. Just consider an algebraic expression on the left-hand side, and let us take another algebraic expression on the right-hand side, and let us give an equal to sign in between these two algebraic expressions. That means we have an algebraic expression on the left-hand side which is equal to another algebraic expression on the right-hand side. So such an expression, this entire expression is known as an identity. From the word identity itself, you can figure it out. Identity, identical, that means two algebraic expressions that are identical to each other can be represented in a form of identities. Now, in today's lecture, we'll be discussing some well-known identities, and using that, we'll be factorizing the given algebraic expressions. So let's get started. First things first, we have to learn factorization using identities. For that, we need to learn some of the well-known identities. So, I'll be teaching you four well-known identities in this chapter. The first identity with us is A plus b whole square is equal to a square plus twice ab plus b square. So this is the first identity, that is a plus b whole square is equal to a square plus twice ab plus b square. Now you'll be telling, Madam, why do I believe that a plus b whole square is equal to a square plus twice ab plus b square? You have to believe me because I'll prove it to you and show. So we have a plus b whole square as our first identity, which gives us a square plus twice ab plus b square. So now a plus b whole square. When I say x square can also be written as x multiplied with x. So in the similar way, a plus b whole square can be written as a plus b multiplied with a plus b. Because a plus b whole square means a plus b is multiplied with itself two times. That means a plus b multiplied with a plus b. Now, what we have over here is a multiplication of binomial. That means we have to multiply this first term with the entire term of the second polynomial that we have, and the second term with the entire term again. So what we'll do is we'll take a first and then multiply it with both the terms of the second binomial that we have. So we'll be multiplying a with a plus b. And then we'll take up the second term of the first binomial and multiply it with both the terms of the second binomial. So from here we have this b, which needs to be multiplied with the entire a plus b. So this will be multiplied with a plus b. So now when we multiply a with a, this gives us a square. On multiplying a with plus b gives us plus of ab. Over here when we multiply plus b with a, it again gives us plus of ab. Now, we get BA. Either we write BA or AB. Both are the same things because 2 multiplied with 3 is equal to 3 multiplied with 2. So BA will be equal to AB. Now we have B multiplied with B, which gives us plus of B square. Now, do we have a like term? Yes, we have. We have AB and here plus AB. So plus AB and plus AB will give us plus 2 times AB. So here we'll have A square plus 2 times of AB plus of B square. Isn't it the same identity I told you initially? That A plus B whole square is equal to A square plus twice AB plus B square. Now you have to believe me because I have proved it and shown to you. Now let's move on to the second identity. The second identity that we need to learn is A minus B whole square, which is equal to a square minus twice ab plus b square. So, you will tell, how ma'am we'll learn so many formulas. You have a trick. The only difference between this a plus b whole square formula and a minus b whole square formula is the difference of this minus sign. In the first formula, we had a square plus twice ab plus b square. In the second formula, when we have a minus b whole square, in this case, we have a square minus twice AB plus B square. Just the difference of this negative sign. Now I'll prove it and show. So we have A minus B whole square. Now A minus B whole square can be written as A minus B multiplied with A minus B. So we have A minus B whole square as A minus B multiplied with A minus B. I explained it to you that x square means x multiplied with x. In the similar way, A minus B whole square means A minus B will be multiplied with A minus B. Again, we have a multiplication of a binomial and a binomial. So this A needs to be multiplied with this entire term of the second binomial. So we'll have A multiplied with A minus B. Now we have to multiply the second term of the first binomial, that is minus B, with the entire second binomial, that is minus B will be multiplied with A minus B. Now what we have to do is we have to open the brackets by multiplying the terms. So A gets multiplied with A, giving us A square. A gets multiplied with minus B, giving us minus of AB. Now we have minus B multiplied with A, that gives us minus of BA. Now minus of BA can also be written as minus of AB, because 2 multiplied with 3 can be written as 3 multiplied with 2. So in a similar way, we'll be writing it as minus of AB. Now what we have is minus B multiplied with minus B. That means we have minus B which is getting multiplied with minus B. Now we know when minus gets multiplied with minus, it gives us positive sign. B multiplied with B gives us B square. This we have learned in exponents and power. So we have plus of B square. So ultimately we have A square. Now what we find over here is we have like terms minus AB and minus AB. Minus AB gives us minus 2 times AB. So we have minus of 2 times AB plus of B square. So our identity has come out. A minus B whole square gives us A square minus 2AB plus of B square. Now let me teach you the third identity. So the third identity that we have is A plus B multiplied with A minus B. So this is the third identity, A plus B multiplied with A minus B. And what does it give? It gives us A square minus of B square. Again, we'll prove it and show it to you. So we have A plus B multiplied with A minus B. So I'll be writing A plus B, which is getting multiplied with A minus B. Now, this is actually a simple binomial multiplication. So in case of binomial multiplication, we take the first term of the first binomial, multiply it with the entire second binomial, and then we take the second term of the first binomial and multiply it with the entire second binomial. So the first term of the first binomial is A. It will get multiplied with the entire second binomial, that is A minus B. Next we have the second term of the first binomial, that is B. So we'll have plus B, which will get multiplied with the entire second binomial, that is A minus B. So from here what we have is A multiplied with A gives us A square. A multiplied with minus B gives us minus of AB. Now we have B multiplied with A. B multiplied with A will give us BA, which can also be written as AB. So we can write plus of AB. And then we have B multiplied with minus B. When B gets multiplied with minus B, we get minus of B square, because plus into minus gives us minus and B multiplied with B gives us B square. So we are left with minus of B square. Now, can you find some terms that will get cancelled out? Yes, I can see. Here we have minus AB and here we have plus AB. So they will get cancelled up, leaving behind A square minus of B square. So this gives us the third identity, that is A plus B multiplied with A minus B is equal to A square minus of B square. Now that we have learned the three identities, let's use them and factorize the given algebraic expressions. Because whenever we have learned the concept, we should know its application as well, that where this concept will be utilized. So we have an algebraic expression given over here and we have to factorize it, but this time we'll be factorizing it using identities. So for using identities, the first step is to simplify the problem first in such a way that we get an identity out of it. I'll explain you. For example, we have here x square plus 8x plus 16. So this x square plus 8x plus 16 can be written as x square this 8x can be written as 2 multiplied with 4 multiplied with x. You will get to know why I have written 8x as 2 multiplied with 4 multiplied with x. We could have written 8 as 2 multiplied with 2 multiplied with 2, but we wrote 2 multiplied with 4 multiplied with x. I'll explain it to you. Now 16 can be written as 4 multiplied with 4, isn't it? Because 4 multiplied with 4 gives us 16, and 4 multiplied with 4 can also be written as 4 square. We have learned this in exponents and power. When bases are same and they are multiplied, then their powers are added. 4 to the power 1 multiplied with 4 to the power 1 will give us 4 to the power 1 plus 1, which is equal to 4 square. So we can write 16 as 4 square. Now just observe. What we can observe over here, the first thing is that consider this x as a. Just consider x is equal to a. Consider this 4 as b. That means 4 is equal to b. Now again we have here 2 multiplied with, I considered 4 as b and x as a. So what is this equation giving us? Isn't it an identity? A square plus of b square plus twice ab, isn't it? So this was the first identity that I taught you, which was a square plus twice ab plus of b square gives us a plus b whole square. I taught you in the reverse way. You have to remember both the ways because you can need it in any form. So over here we have a square plus b square plus twice ab. So this identity is equal to a plus b whole square. What is a in this case? In this case, a is equal to x. So we'll write x and then we have a plus b whole square. What is b in this case? B in this case is 4. So we have plus 4 and then we have to take the whole square of it. What I have written x is equal to a, 4 is equal to b, these things are just for your understanding. In your exam, you don't have to write these things while solving questions. What you have to do is, you have to just keep this thing in your mind that in this identity or in this algebraic expression, which terms are represented as a, which of the terms are represented as b, and accordingly you have to make the identity. So the identity that I get is x plus 4 whole square. So this will be our final answer. This is the answer. So we have factorized the given algebraic expression using the first identity that I taught you, which was a plus b whole square is equal to a square plus twice ab plus b square. Now let's try solving another problem. So the example given over here is 4y square minus of 12y plus 9. So this is an algebraic expression that has been given to us. What we have to do? We have to factorize it using identity, using a suitable identity. Now this is up to you. You have to decide that out of the 3 identities that I taught you, which identity will be utilized in this particular question. So let us proceed first. This 4y square is the first term. It can be broken down and written as 2y whole square, isn't it? Because 2y whole square means 2y multiplied with 2y, which is equal to 4y square. So what I did it, I wrote 2y square in this form, 4y square in this form, 2y whole square. Now what we have over here is just forget this middle term first and then focus on the third term. The third term is 9. 9 can be written in the form of whole squares. What we are doing is, we are breaking this first term and the third term in the form of whole squares. So 9 can be written as 3 whole square, because 3 whole square means 3 multiplied by 3, which gives us 9. So we have over here plus of 3 whole square. Now come to this middle portion, minus 12y. Now minus 12y can be written as minus 2 multiplied with 2y multiplied with 3. Just check it. 2 multiplied with 2 gives us 4. 4 multiplied with 3 gives us 12. We have a minus sign, so we get minus 12 and then y. So this minus 12y can be broken as minus 2 multiplied with 2y multiplied with 3. Now you will be asking, why did I broke minus 12y in this form only? Because when I broke down minus 12y in this form, I will be getting an identity. Let's check how. Let us consider this 2y as a and this 3 as b. So over here what we get? We have minus of 2 multiplied with 2y has been considered as a. So we have a over here. and 3 has been considered as B. So we have B. Now, what was this identity? A square plus B square minus 2 times AB. Do you remember? I remember. We had an identity A square minus of 2 times AB plus of B square is equal to A minus of B whole square. This was the second identity that I taught you. So, we'll be using the second identity from over here, and this is the reason why I broke minus 12y in this form, because when I broke it in this form, it gave me minus 2 times A and B. So, from here, we'll be using the second identity and solving this problem further. So, we know that A square minus 2 times AB plus of B square gives us A minus B whole square. Now, what we have considered as A over here? We have considered 2y as A over here. So, it will be 2y. And then we have to give a minus sign because this identity is equal to 2y, A minus B whole square. So, A is 2y and B is 3. So, we have 2y minus 3 whole square. This will be our final answer. Moving on to the next problem. The next problem that we have is 49p square minus 36. So what we can do over here, we can write this 49p square in a perfect square form. How? Because we know that this 49 can be written as 7 multiplied with 7, which can also be written as 7 square. And we have p square over here. So ultimately this 49p square can be written as 7p whole square. Because 7p whole square means 7p multiplied with 7p, which is equal to 49p square. Justified, right? 49p square can be written as 7p whole square. Our motive is to break each of the terms in a perfect square form. Now 36. What about 36? 36 is actually 6 multiplied with 6, which can also be written as 6 square. So here minus 36 will be written as minus of 6 square. Now, by looking at this expression, can you recall an identity that I taught you? Just consider this 7p as A. That means A is equal to 7p. And just consider this 6 as B. That is B is equal to 6. Now, isn't this the third identity A square minus of B square? What was A square minus B square? I taught you that A square minus of B square is nothing but A plus B whole multiplied with A minus B. This was the third identity that I taught you. So we'll be using the third identity over here. When you'll be solving the problem, you'll get to know which identity you have to use in the given question. So what we'll write? A square minus B square is equal to A plus B multiplied with A minus B. So A over here is 7p. It will be added to B. Over here is 6. So 7p plus 6 whole multiplied with A minus B. A over here is again 7p. And then minus B, which is 6. So our answer will be 7p plus 6 whole multiplied with 7p minus 6. Moving on to the next problem. The next problem reads, factorize A square minus 2ab plus B square minus C square. Now, forget this minus C square and focus on this part. That means the first 3 terms of the expression. A square minus 2ab plus B square. Isn't it the second identity that I taught you? That A square minus twice AB plus B square gives us A minus B whole square. Yes, it is. So we can write A square minus twice AB plus B square as A minus B whole square. And then we are left with minus C square. So we'll write minus of C square. Now, just consider this A minus B, like just consider this in your head, okay? Just consider this as capital A and consider this as capital B. So what we are getting? We are actually getting capital A square minus of capital B square. Isn't it the third identity that I taught you? That capital A square minus capital B square will give us the sum of the terms, that is A plus B whole multiplied with the difference of the term, that is A minus B. So we'll be using the third identity to solve this given problem. Now what we have to do is we have to take the first term, add up to the second term, whole multiplied with the first term subtracted with the second term, because this is what the identity says. A square minus of b square is equal to a plus b multiplied with a minus b. So what we'll be doing, we'll take the first term which is equal to a minus b and then add it up to the second term, that is c. Whole multiplied with the first term, that is a minus b, subtracted with the second term, that is minus of c. So this will be our answer of the given question. I think you're enjoying solving the problems. So let's solve another problem. So the problem given to us is factorize m to the power 4 minus of 256. Now, how can we write m to the power 4 in the form of a perfect square? We can break this m to the power 4 as m square multiplied with m square, because we have read it in exponents that when bases are same and they are multiplied, their powers are added. That means it will ultimately give us m to the power 4. So m to the power 4 can be written as m square multiplied with m square, which ultimately can be written as m square whole square, isn't it? So we'll be writing m to the power 4 as m square whole square. Now what about 256? Whose whole square is 256? We have 16 whole square as 256, because 256 can be written as 16 multiplied with 16, which ultimately can be written as 16 whole square. So 16 whole square gives us 256. So we have a minus sign in between, and then 256 can be written as 16 whole square. Now, which identity will we use over here? Just consider this as A, okay? And just consider this as B. What is the identity? Over here we are getting a square, that is m square whole square. So it is a square minus of b square. This was the third identity. A square minus b square is nothing but a plus b. That means adding the first two terms and then whole multiplied with subtracting the first two terms. So we have to do a similar thing over here. The first term over here, a is m square and b is 16. So a square minus of b square, that means m square whole square minus 16 square will give us m square plus 16. Why? Because we have to write a plus b. In place of a we have m square, in place of b we have 16. And then whole multiplied with a minus b. A we have as m square. So m square and then minus b. Minus b is 16 in this case. So we have this. Now, we can further break this down. M square plus 16 will be written as it is m square plus 16. Now, what we can do over here is m square can be written as m whole square. And then 16 can be broken down and written as 4 multiplied with 4, which is actually 4 square. So, 16 can be written as 4 square. Now, what we can do is we can use the same identity, that is this identity number 3 again in this question. A square minus of b square will be equal to a plus b multiplied with a minus b. So over here we have m square plus 16, and then what we'll have is, the first thing we'll have is m plus 4, because a square minus b square is a plus b. So we'll have m plus 4. And this will be multiplied with m minus 4, because a square minus b square is equal to a plus b multiplied with a minus b. So this is our final answer. Now that I have taught you 3 identities and we have even learned the application of those 3 identities. But did you observe anything in all the questions that we solved previously? I observed. In all those questions, we got the terms in the form of perfect squares. But what if we get an expression in which the terms cannot be reduced in the form of a perfect square? So for that, we have another identity, that is identity number 4. And this identity number 4 is used when the terms of an algebraic expression cannot be broken down as perfect square. So the identity reads, x plus a whole multiplied with x plus b gives us x square plus a plus b within bracket whole multiplied with x plus of ab. Now let's prove it. So we have x plus a whole multiplied with x plus b. What is this? This is just a binomial multiplication. I have already taught you this. So to solve this, we have to take the first term and then multiply it with the entire second binomial. That is x multiplied with entire second binomial x plus b. Then we have to take the second term, that is plus of a, and multiply it with the entire second binomial, that is x plus b. Now what we have to do is, we have to multiply them. Open the brackets and multiply. X multiplied with x gives us x square, plus of x multiplied with b gives us bx. Now we have plus a multiplied with x, that gives us plus ax. Now a will be multiplied with b, so plus a multiplied with plus b gives us plus of ab. Now what we can do is, from this bx and ax, we can take a common term outside, and I taught you this factorization in the previous lesson, factorization using common factor. So bx and ax has a common factor, that is x. So we will be taking x outside the bracket and take the remaining terms inside the bracket. So x square will be written as it is x square, and from bx and ax we will be taking x common outside. So in order to make the first term, we have to write b. And in order to make the second term, in the second term we have ax, we have taken x common outside, so we are left with a. And then ab will be written as it is. So finally we get this identity as x square, plus of b plus a can be written as a plus b as well. So we'll have a plus b whole multiplied with x plus of ab. So we have just proved the third identity that I taught you. X plus a multiplied with x plus b will give us x square plus of a plus b whole multiplied with x plus of a into b. This identity will be used when the terms of the expression given to us cannot be broken down as perfect square. Now let's learn the application of the identity number 4 that I taught you. So the question given to us over here is factorize x square plus 5x plus 6. Now let's write it in a different form. Here we can write x square as it is x square. Now 5 can be broken down and written as 2 plus 3. And then we have x over here. Again 6 can be broken down and written as 2 multiplied with 3. Now just observe one thing and relate to the identity that I taught you. This x square can be written as x square. Now this 2 plus 3x, just consider this 2 plus 3 as a plus b. So, and we have x over here. So we can see that in this question we are getting a as 2 and b as 3. And then 2 multiplied with 3. That means we have taken a as 2. So 2 can be written as a and then 3 can be written as b. So a multiplied with b. Isn't it the fourth identity that I taught you just now? Yes, it is. That is x square plus a plus b x plus of ab. It is just that in this question, it has been represented in a different form, but originally it is following the same identity. So x square plus a plus b x plus of ab was equal to x plus of a whole multiplied with x plus of b. So we will be using this x plus a plus x plus b in order to solve the question given to us. So from the question we have figured out that this 2 is nothing but the value of a and 3 is the value of b. So x square plus a plus b x plus of a multiplied with b is equal to x plus a multiplied with x plus b. So in place of x we will write x. In place of plus of a we will write 2 because here a is 2. What we have to do is to compare the question with the standard identity that we have learned. Just this. Now we get x plus b multiplied with x plus b. That means plus x plus of what is b in this question? In this question b is equal to 3. So we have 3. So this will be our final answer, that is x plus 2 whole multiplied with x plus 3. Moving on to the next question. Find the factors of y square minus 7y plus 12. In order to find the factors, what we have to do is we have to factorize this algebraic expression first, and when we factorize this, we will be getting the product of the factors of this given algebraic expression. So we'll be getting this entire algebraic expression in the form of the product of its factors, and from that product we can simply figure out the factors of this algebraic expression. So the first thing is to factorize it. Now how will we factorize it? Let's do it. So what we have to do is y square. It can be written as y square. Let's leave it as it is. Now we have minus 7y. Now minus 7y can be written as minus of 4 times y minus of 3 times y, because minus 3y minus 4y minus 3y gives us minus 4 minus 3 gives us minus 7, and we have y as common, so we'll get minus 7y. I've just simply broken it up in two different terms, that is minus 4y and minus 3y. Now again we have this 12. I have to break down this 12. What will I do? I'll write 12 as minus 4 multiplied with minus of 3. 4 multiplied with 3 gives us 12, and minus minus gives a positive sign. I'll explain you why I've taken 12 as minus 4 and minus 3 and not as 4 and 3. I'll explain you, okay? Now what happens? Now we'll write y square as it is from these two terms, that is minus 4y and minus 3y. Can you see anything common? Yes, I can. Y is a common term. So let us take this plus sign and then over here y as a common term from both the given terms. Now what we are left with in the first term? We are left with minus 4. So we'll be writing minus 4. And from this minus 3y we have taken y outside. So we are left with minus of 3. Now we have plus multiplied with minus of 4 multiplied with minus of 3. The reason why I took minus 4 and minus 3 is to make this question look similar like the identity number 4 that I taught you. The identity number 4 that I taught you was x square. I'm just writing it for the sake of understanding. Don't focus on this. Don't write this in your actual answer. It is just for the sake of understanding. The identity number 4 was x square plus of a plus b times x plus of a multiplied with b. And this used to give us x plus a whole multiplied with x plus of b. Now, what I have written 12 as minus 4 and minus 3 is that when I have a plus b of y, then a over here is minus 3 and minus 4 and b over here is minus 3. I have to take these two same numbers in the product form in order to make this identity. So I have taken minus 4 and minus 3 in the product form, which will give me this term of the identity, that is AB. And thus we can write this identity in the form of x plus a and x plus b. How? Over here x is y. We don't have x, we have y. So we'll write y plus a and y minus a, because y square plus of a plus b of y plus of ab will give us y plus a multiplied with y plus b. Over here a is minus 4. This is actually a. And what is minus 3? This is b. Again over here also minus 4 is a and minus 3 is b. So y plus 4 will be equal to y plus of minus 4. Again in place of y plus b we have y plus of minus 3, because b is minus 3. So ultimately what we'll get is y minus 4, because when the bracket opens plus minus becomes minus. Again in the similar way we'll have y minus of 3. So from here we can say that y plus 4, y minus 4 and y minus 3 are the factors of the given algebraic expression. So in this question we use the identity number 4. Another question must rise in your mind, that is my answer correct or not? In order to check your answer, what you can do is just go to this answer. This answer is a product of two binomial. What you have to do is do the multiplication of the two binomial. When you multiply both these binomial and then solve the like term, you will end up getting the question. If you end up getting the exact question, that means your answer is absolutely correct. Moving on to the next question. Obtain the factors of x square minus z square minus 4z minus 12. So in this question also we have to obtain the factors. In order to obtain the factor, we have to factorize the algebraic expression first. In order to factorize the algebraic expression, let us write it in a simplified form. So z square will be written as z square. Now, what about this minus 4z? Can I not write minus 4z as minus of 6z plus of 2z? Yes, I can. Now again I have minus 12. I can write it as, let me give a positive sign first, and then minus 12 can be written as minus 6 multiplied with 2. 6 multiplied with 2 gives 12, plus into minus gives us minus. Done. Now what we have to do is, we'll write z square as it is. From these two terms, we'll be taking z common outside. So we have plus, we'll give a bracket and take z common outside. The first term left will be minus 6, and from the second term we have taken z common outside, so we have plus of 2. Plus of minus of 6 multiplied with 2. Now again, you can see that this expression is resembling the fourth identity, that is z square plus of a plus b z plus of a multiplied with b. This is the reason why I wrote minus 12 in this format, such that I can compare it with the identity number 4 I already know. Z square plus a, this minus 6 is a and this 2 is b. A plus b z plus of a multiplied with b. And we know that this gives us z plus a multiplied with z plus b. So z plus of a. In place of a what we have? Minus of 6. Now this will be whole multiplied with z plus of b. So we have z plus of, in place of b we have 2. So we can write 2 over here. So our final answer will be z minus 6 multiplied with z plus 2. So from here we can say that the factors of this particular expression that was given to us are z minus 6 is one factor and z plus 2 is the second factor, because we have factorized this algebraic expression in the form of the product of its irreducible factor. These are irreducible factors. So the factors will be z minus 6 and z plus 2. Let's try solving another problem. We have to find the factors of 3m square plus 9m plus 6. Now, in this question, you can observe one thing, that in each of the term, we have a common factor. So let's use the common factor method first, and then we'll be using the identity. So from the common factor method, I can see that I can take 3 common outside from each of the term. When I take 3 common outside from the first term, I'll be left with m square. So m square will be left from the first term. Now I'll add it up to the term that is left in the second term. So when I take 3 outside common, this 9m can be written as 3 multiplied with 3m. I have taken this 3 common outside, so I am left with 3 times of m. So 3 times of m is left. Now what about 6? 6 can be written as 3 multiplied with 2. I have taken 3 outside as the common factor. I am left with 2. So here what I am left with is 2. Now what we have to do is, we have to forget this 3 and solve this thing that is within the bracket. So m square can be written as simply m square. Instead of 3m, we can also write 2m plus of m, because 2m plus m gives us 3m. And in place of 2, we can write 2 multiplied with 1. Now, in the next step, what we have to do is, we have to again write 3 as it is, m square as it is. Now from these two terms, 2m and m, we again have a common factor, that is plus of m. So within bracket, we'll write the leftover term and take m outside first. So from the first term, when I've taken m outside, I am left with 2. So I'll write 2 in the first place, and then it will be added to. When m is taken outside, then I am left with 1. So 2 plus 1, and here I have plus of 2 multiplied with 1. Now you have to compare this term within the bracket, this entire expression within the bracket, with the identity number 4 that I taught you. That was x square plus a plus b x plus of a multiplied with b gives us x plus a multiplied with x plus b. So over here we have m square plus of, can we say that this 2 is a and this 1 is b? So it is a plus b m plus of 2 is again a and 1 is b, a multiplied with b. So this is identity number 4. So we'll simply just put the identity. So what we have to do, m square plus a plus b m plus of ab will give us m plus a. In place of a we have 2. Whole multiplied with m plus of b. In place of b what we have? 1. So we'll write m plus of 1. So from here we can say that the factors of this given expression are 3, m plus 2 and m plus 1. Because an expression, an algebraic expression can be represented as a product of its irreducible factors. I have represented the expression as a product of its irreducible factors. So the factors are 3, m plus 2 and m plus 1. So this was the end of today's session. Thank you so much for joining me on Study Room. We will be meeting in the next lecture where I will be teaching you the division of algebraic expression.